We are the Aeritae work group, and we are developing a help desk chatbot. My name is Brian Engelbrecht.
My name is Jesse Kunze.
And I'm Andrew Zinke.
So today we're going to go over a few things with you, give you a little overview of the company and what they do, talk about the problem they had and then the solution we came up with for it. We'll go over the schedule that we had planned out for the beginning of the semester, then we'll talk about the progress we had throughout and then our current status. We'll give a demonstration of the project so you can see what it looks like from the user's perspective as well as the help desk agent's perspective. We'll discuss some of the risks and issues we encountered along the way, give a post-mortem summary of how we think we did overall, and then discuss some of the next steps we think would be good for future development of the project. So Aeritae is a consulting company that helps clients implement ServiceNow. And this is basically a service management software that can be summarized as a ticketing system. And what that means is any user who has a problem or a request for help can fill out some details, make a report, and then send it in. And then the help desk agents can go through these tickets, figure out what these users' problems are, forward them to the correct department that can help them out. And then it's that process over and over. So it fills up, and then they clear them out, and that's how they can manage how well they're serving their customers. Our mentor is Chris Richter, and he has been a great help throughout this entire process. So what Aeritae needs is a chatbot to act as a front line for their technical support group. As you can see in the diagram here, it's actually a very simple setup. The end user will interact with the chatbot. It will get some details about what issue they're having, and then it will create a report that is then sent to ServiceNow and stored as a ticket. And then ServiceNow will categorize it, but then it can be used by the help desk agent, and then they can read it, see what the deal is. They can contact them, stay in contact with them, and then eventually just get them the help that they need, and then close the ticket. The chatbot should talk to the user to determine their issue, and then once it has what it needs, provide the user with a solution. Now, this can happen one of two ways. First is just get the details that it needs, create the report, and send it to ServiceNow. This will actually happen in every instance, but in a case where their problem is rather simple or there is a knowledge article that can allow them to just walk through and read, figure out the problem for themselves and fix it, avoiding any further contact with a live agent, it will do that. So it will add a link into its own actual chat bubble and then provide it that way. So there's a faster and then a longer situation here, but in the end, it will always get them the help that they need. So the tools that we selected to use for this project that we thought would make it easiest to develop was the Microsoft Bot Builder SDK. We paired this with Node.js. Our other option was C#, but our teammate Jesse had some experience with Node.js and assured us that it was pretty easy to work with and learn. Microsoft Bot Builder also had a great length of documentation that was easy to read and learn, and based on how it was designed, it seemed like the best implementation for what we were trying to create. We also used the ServiceNow developer instance for testing. This was included with ServiceNow's website. Basically allows any developer to have their own miniature database that receives all the reports they generate with the chatbot that they're developing, and then they can go in and see if it's getting any errors or it's not filling in fields correctly, and they can fix it that way. So a dialogue is the main part of the MSBot framework. You'll hear us talk about it a lot, so I thought we should just show what a single dialogue looks like. You can basically break it into just two functions. The first one is the prompt that it gives right away. So this is what the chatbot itself is saying, or in this context, asking. And then the second function is after the user's input, and they have responded to the question. And the code, which we've cut off for the sake of the screenshot, is basically all the code that will determine what it does after it registers their input and figures out what exactly the user had said. So now I'll pass off to Andrew, and he'll discuss the schedule and give you a brief demonstration.
So for our schedule, we've had it planned out pretty much from the start. We broke it down into 4 sprints of about 3 weeks long each. For our first sprint, we wanted to have each of us research individual chatbots and then come together as a group so we could decide on which one would be best for us to use. We ended up deciding on using Microsoft Bot Builder, as Brian said. And then we wanted each of us to create a basic chatbot on our own so that we'd have basic understanding of what to expect when working with the chatbot in the future. In sprint number 2, we wanted to have the chatbot be able to parse through user input and detect keywords. And when I say parse, I mean have it go through the initial conversation that the user input and look for specific words that can help it go through the decision tree, which is another thing we wanted in sprint number 2. And the decision tree was given to us by Chris, and what it is a 3-level tree with keywords at each level to help categorize what the issue is. Level 1 being something as broad as instant or a request or a password, with level 2 being a little bit more in detail, talking about whether it's with an email or database or software. And level 3 being what the actual issue is, saying it won't start, or I can't get into it, or I'm having issues updating my database. In sprint number 3, we wanted to be able to have the chatbot generate full reports using ServiceNow. And with the full reports, we wanted it to fill out things such as who the caller was, what the category and subcategory are, and a full description of what the problem is. We also started working on embedding the chatbot at this time, and we wanted to embed it into a web page so it wouldn't just be a bot emulator. And for our 4th and final sprint, we started looking into AI implementation with Lewis, and also looking into keyword pairing. So for our current progress and current status, we have finished the report and ticket generation. The reports get fully filled out based on what the user inputs. We have started working on embedding it, but we are running some issues that Brian will talk about later. We have looked into a possible Lewis solution. Brian will also talk about that in the future. And we have started working on upgrading a single keyword system into the keyword pairing. And what the keyword pairing is a way for the chatbot to be able to pick up multiple keywords at once so that the user doesn't have to go through each level in the decision tree one at a time. The keyword pairing is supposed to make it so the user has a more fluid experience with the chatbot. Say they put in, I'm having an issue with my email. It'd pick up both issue and email and send them straight to level 3 and give a proper prompt to get the last remaining keywords, such as, having issues starting up, or is it a logging in issue, or something like that. We've ran into a lot of issues with this keyword pairing, a few of them being that some of the keywords at the level 2 and level 3 in the decision tree, they were the same even across layers. So we had to make the language more apt for each situation. We've also have a current issue right now where if they stop with a level 2 keyword, say they put in a level 1 and a level 2 keyword, the level 3 keyword gets picked up at random. We've tried changing the keyword just to something that will never be input, and it still gets picked at random. So we're trying to figure that out still. Our current style implements a sub-parsing function. So what I mean by that is when a keyword is found in level 1, it'll call the sub-parsing function to look for another keyword in the level 2. And if level 2 keyword is found, it'll continue on to level 3. So now I'll give you a live demonstration of it. So I'll just swap on over to the emulator here, and you can see it's already been woken up. You just type in something like hi, and it'll say, thank you for choosing Aeritae. What is your full name? I'm just going to input a name here that's already associated with ServiceNow. And it'll say, nice to see you. How can I help you? So I'm just going to show you a basic one that just goes into one level, and I'm just going to say, I forgot my password. And you can see it found the password keyword and was able to figure out that that's the problem right away and give a knowledge article in this link right here. Now I'm going to show you what it looks like to go through the bot without using any keywords. So I'm going to wake the bot up again just by saying hi. I'm going to enter the name AbleTutor again. And it's going to say, how can I help you? So I'm just going to put in, I'm having an issue. So it responds with, sounds like you're experiencing an incident of some kind. What are you working on? So it prompts the user to go into a little bit more detail on the issue that they're having. I'm just going to say, it's with my email. And it picks up on that email keyword again, and it gives another prompt saying if you're unable to log in, unable to start the program, or just an error message with it. So I'm just going to put in, I can't log in. And it will respond with, so you're unable to log into your email. As you can see there, it found all the keywords that it needed to reach the end, and it was able to generate the report and send it to ServiceNow, as it says here. So now I'm going to show you what it looks like with the keyword pairing. I'm going to wake it up, put in the name, Able Tutor, and I'm just going to put in, I'm having an issue logging into my email. And as you can see, it gets the same response as it did with just going through each tree, each level individually. It's able to find all 3 keywords and make the report off of that. So now I'll switch over to the ServiceNow webpage that we have, the developer instance, and refresh the page. And you can see here that it was just created just now. And if you go in, you can see the name, the category being inquiry or help, with the subcategory of email. And down here, it's a short description based on the keywords that we found. In this case, it was incident, email, and login. And the full description is what the customer input from the start. So now I'm going to pass it off to Justin, and he'll talk about the reports.
Thank you. So Andrew just showed you a little gist of what it looks like to, from the help desk's perspective, to see the ticket. The reason he said Able Tutor was his name was because that's already in ServiceNow, meaning the help desk agent will be able to grab Able's contact information, maybe his phone number or whatever, or his employee number, and be able to help him better with the issue. The category and subcategory were obviously assigned by the bot. Everything yellow up there was something that the bot provided to ServiceNow to help generate the ticket, including the assignment group going to service desk, the contact type being web chat coming from a chatbot. The description could easily be changed to actually list the full conversation that the bot had with the user in case the categorization isn't working correctly for some reason. So the help desk would be able to look through the chat and say, okay, well, this is what the person meant, and then go through it and help them out. And this is what it actually looks like on the back end, the JSON data. As you can see, we use session data to hold everything. The reason for that is because we didn't use session data before, and when we tried running 2 bots at once, the data was actually getting mixed up between the 2, and then we Googled it, and apparently you're supposed to use session data for that. So we're using it for things like the user's name, the category the bot decides, a subcategory. A few of these are static. For instance, if you're communicating with the bot, the input type will always be a web chat. You're not going to be able to call the bot or something. And that's all about I have to say about the reports. I'll hand you on over to Brian to talk a bit more about embedding and Lewis.
Thank you. So basically, the end goal of embedding the chatbot is to get it to appear directly on Aeritae's website. This could either be in the form of a tab that expands upward, a link to another window, or even just appearing right there in a simple iframe tag. But essentially, you just don't want the user to have to install Node, install the emulator, run the emulator from a console, and then get the help they need. So we did encounter a few struggles with trying to get this to work. Since we committed to a Microsoft product for building the actual bot, we had already limited ourselves in things that were compatible that could host it or deploy it. After a few hours of research and trying to find out other resources, we did establish that Azure was our best bet. And in retrospect, we probably wanted to create this Azure registration first because it has all sorts of options for developing right there in the portal, but we still cannot actually upload any of our code. So that is what we're currently working on now. And it didn't help that we fell a little behind in this due to a recent loss of communication with a teammate. I am now starting from scratch with this because all progress was actually lost, but this is definitely a goal that we think will be completed that we can submit to Aeritae. Lewis, as mentioned before, is the AI aspect that we are looking into. This is the language understanding intelligence service also provided by Azure. Basically what this would do is make the chatbot very flexible and expandable, and it would make maintenance very easy in the future because it focuses on getting a user's intent based on their input. It would actually, a neat feature of this would be that any input it doesn't recognize, it would be placed in one large library of unrecognized input. And then a designated worker would go through, figure out what all these users are trying to say that it doesn't recognize, and make new entities that it does recognize. And so it's actually learning through experience. We did learn that this very clearly would cost some money down the road on a per usage basis. So Aeritae is interested in this implementation, but not certain at the moment. So as per Chris's request, we have just elected to make a high-level design document to show an overview of how it would work and what this chatbot would look like and if it is a better option for them. And now I'll hand it back to Jesse for some concluding thoughts.
So I'll start kind of with some issues and risks we had during this semester. The first issue we had was communication. As Brian said, we did lose contact with one team member during the last few weeks of the semester, and they were the ones working on embedding. And because of the way the embedding works, it's not like there's anything to upload on GitHub that we could just scrape from what they've made. So we had to start over with our knowledge of Azure and everything to kind of get the webbot or get the embedding working. Additionally, accountability was something we kind of had a problem with at first. For instance, we didn't make people show what they had gotten done in our group meetings, so we were just taking their word for it, and in some cases we exaggerated what we had done to each other in the group. So then later on in the later weeks, we were like, oh, I thought this was done, and it's like, well, this is 75% done. Later in the semester, we got all that cleared up, but that was definitely something we would do different from the start. Equal understanding was another big issue. Since I had a lot of more experience with Node than the other people in the group, I started out working on the dialoguing and report generation. We originally thought that would only be something like 10 to 20% of the actual work, but as it turns out, that's basically the core of the actual bot itself. So not only did the other team members have to learn Node.js and Microsoft Bot Framework and all those things, but they also had to kind of interpret my own code base to see how I put stuff together and how they could extend functionality onto my system. Lastly, one risk was that it was very self-driven. On the positive side, it was really cool because basically all we got told by Chris was, here's what we want done, you can do it however you want, which is really cool because we got to choose exact frameworks we wanted, and we do think we made the right choice with frameworks. But on the flip side, that's a little bit less structure for support for stuff like Node.js and Microsoft Bot Builder, since we were supposed to be the experts on it. In that case, we had to rely on Stack Overflow and Wikipedia and stuff to figure out how that all works. And a few more post-mortem thoughts. We did a few things well. One of the big ones was regular communication with our sponsor. We had some ideas of what we wanted, and as we presented them to Chris, sometimes he said, that's not really what we're looking for, so we didn't waste time developing stuff that he didn't even want. Or if we missed something, he said, well, you guys aren't really talking much about this, and then we learned stuff that he actually wanted that we didn't get the first time we talked with him. Additionally, we got a lot of stuff done in the first half of the semester. That was really nice because as we had these embedding and communication issues, it kind of helped smooth out the average rate of getting stuff done. Although it would have been better if we would have been able to keep that streak going on, but we had to implement more complex things that took longer than just a dialogue. There are a few things we would change, one of them being more discrete goals earlier. For instance, one of our goals was develop the keyword pairing. I mean, that's very vague and a very big goal to have, and that's the end goal we wanted, but to have that as one goal is kind of unclear because then a person is working on that one goal for however long, and if they have the wrong idea, it will take a long time before we're able to correct that. A better goal might have been implement keyword pairing for this one part of the system, and then once we see that worked well, extend it to the rest of the system. Like I said before, more accountability with checking each other's work and making sure everyone's getting stuff done. That would have been something we would change. The last thing we would change is more in-person group programming. For the first part of the semester, we did a lot more remote stuff like over GitHub and GroupMe and kind of communicating that way. And then in the last several weeks of the semester, we had more times where we're like, hey, let's just meet on Sunday, try and get some work done. In that case, we had a lot more feedback between each other, which helped get our ideas actually implemented faster and stop things that we didn't actually want to implement from happening. So just a few of the things, the technologies we learned. Node.js and Bot Framework go together, and then we learned how to make REST APIs on Node for ServiceNow to communicate with ServiceNow to send the reports to them. And some future steps we have. Like Brian said, we're working on embedding the web page now. We're pretty confident about that. But in the case that we don't get it done, any future people working on this project, that would probably be priority number one. The second priority would probably be more natural language processing. Right now, each of the branches on the decision tree only have 3 or 4 keywords, meaning if the user doesn't say one of those specific keywords, it might get lost in the bot and then it'll be a negative experience for the user. So adding more keywords to each branch would be very beneficial. Additionally, with Node.js, there's a lot of NPM packages for spell checking. So if the user misspells something, it can autocorrect it before sending it to the parsing part of the bot. And then even though they spelled a word wrong that was a keyword, the bot caught that, fixed the spelling mistake, and then processed it as they should have. Finally, implementing Lewis would help a lot with even preventing having to do so much work with natural language processing, because Lewis itself handles all of that stuff very nicely. So it would be a choice between the two. If you wanted to go with Lewis, you could probably skip a bit of the natural language processing work, but if you wanted to skip Lewis and not use Azure as much, just go straight into the natural language processing and try and fix that up. So that was all we had for today. We had a lot of fun working on this. We learned quite a lot. Did anyone have any final questions at all?
A couple.
Sure.
I know you kind of left it to say, okay, we're going to do this document, turn it over to Chris to say, do you want to do Lewis? Is that document good? Would you, if you were Chris, think pursuing Lewis is a good thing?
I mean, yeah, it's definitely a good thing if you think that the net gain versus the net financial loss would be overall beneficial to the company, because I haven't found any weaknesses in it so far, except for the fact that if a lot of people use it, it just makes it more expensive because it is a per message basis. So that's really the only drawback I've found.
And then the other one, you said if you could get more relevant keywords would be good. Do you think you could automate finding those by going back through histories of previous calls? I mean, automate that process. It says if I see this, I end up with that as a problem.
We could add a way for the bot to store words that were unable to be determined what they meant. There wouldn't really be a way to assign it to something automatically. That would have to have some human intervention of seeing what the user might have thought, because the bot can't really tell what the user thought, but that's more like a human instinct type of thing. If we use Lewis, as Brian said, it would really help a lot with that, since Lewis more easily captures these words that they don't understand the intent of and try and learn from them itself. So that's why we thought Lewis would be a better net benefit than working too hard on the actual language processing.
Thank you.
Cool.